Chapter 2 in Pre-Calculus. We're going to start looking at trigonometry, and we're starting with a review of writing angles in standard position and describing all angles based on the reference. So a quick little warm-up here just to refresh us. Name the angle drawn at right in three different ways. The three ways this angle can be represented are as angle DEF, where you start from this end and work that way, angle FED, which is obviously working the other way, or simply angle E, where we use the vertex as the only letter needed to refer to the angle. Name the vertex of the angle drawn at right. Well, just gave away that answer. That's angle E. Naming the two rays that make up the sides of the angle. So we have one ray here that spans from E to D, and then another one here that spans from E to F. So we have the two rays ED, and EF. All right. What is the measure of the angle at right? Well, no need to dig out your protractors. That was a toughie. There you go. And how many degrees are in one rotation or one revolution? That would be of a full circle. And of course, we know that. All right. So let's get on to describing these things formally. In geometry, an angle is formed by two rays, as you saw on the last page, with a common vertex. They must come from the same place. In trigonometry, angles are often interpreted as blank of a ray. And I think the most appropriate response for this blank would be a rotation of a ray. The starting position of an angle is called the initial arm. The final position of the angle is called the terminal arm. So I'll give you an opportunity to label the two arms on this diagram in your notes. So go ahead and hit pause now. We'll go over the answer when you come back. Okay, welcome back. So wherever we decide to start our angle, this will be the initial arm. And then we rotate from there. And wherever we stop, that is our terminal arm. If the direction of rotation of the angle is counterclockwise, meaning we go that way, then the angle is considered positive. I'm guessing you can understand what goes in the next blank there. So this would be if the angle goes that way instead, so that's clockwise, and those are referred to as a negative angle. Use the angles below to draw a positive angle. So a positive angle would be one that rotates from here in the counterclockwise direction, and a negative angle would be one that rotates in the clockwise direction. So it would go all the way around like that and terminate on your terminal arm there. So that's your negative angle. Whoa. Rein it in. Here we go. Drawing angles in standard position. So the angle is drawn on your regular Cartesian plane, or Cartesian coordinate plane if you want. The one we always work with in math. The vertex of the angle must be located at the origin, which is obviously the 0, 0 spot on the Cartesian plane. The initial arm of the angle must coincide with the x-axis. Now this will also apply in the physics we're doing right now with all the vector work. We always draw an angle in standard position, or the components of an angle, with beginning in the x-axis, the positive x-axis. All angles are measured from there. Which of the following angles are drawn in standard position? So we can only include ones that have an initial arm on the x-axis and then a terminal arm elsewhere. So this one is drawn in standard position. This one does not have an initial arm on the x-axis, so it is not in standard position. This one here is your initial arm, and it is on the positive x-axis, so that one's good. And again, 2 arms, and it doesn't start at the origin either, so there's a lot of things going wrong with this one, and that one is not in standard position. So we're going to draw the following angles here using our protractor, so you can go ahead and do this in your notes. First thing, 56 degrees. Now we have to draw these in standard position. So you can just move your protractor and set your crosshairs right at the origin, because that's where all of our angles are going to originate from. At 56 degrees, so you can draw your line out, put your dot at 56, and there's our angle. Alright, so let's try another one. 120 degrees. Again, center your crosshairs on the origin of your Cartesian plane and find 120 degrees. Start your line from the origin and go straight to the dot that you made. Okay, nothing too groundbreaking here. 210 degrees, it gets a little more difficult when we extend past 180, so if you only have a half protractor, which I'm assuming most, if not all of you do, you might actually just have to flip it upside down and then do a pretty simple calculation just to recognize that 210 is 30 degrees past 180. So I fortunately have a full 360 degree protractor here, so instead of going 180, flipping my protractor, going 30 more, I can just go right to 210. But I'll show you how to do it the other way in the next example. Try to hit your origin a little better than I did, but I'm in a car right now, so I have an excuse at least. Alright, so the angle 315 now. Again, this one is well past 180, so we're going to have to deal with a flipped protractor again, and hopefully not unwillingly rotating it, or shrinking and growing it. Come on, protractor. Okay, it's crosshairs centered on the origin, and we are looking for the angle 315 degrees. Now, a couple ways to approach this. We know that this arm here, this vertical below the x-axis, is at 270 degrees. So we could go from there and then add 45 degrees to get to 315. Or of course you could go all the way to 360 and then subtract 45 degrees to get to 315, sorry. So 45 degrees is the one we're looking for. So just draw it out, find your 45, and of course, since this is a positive angle, we would label this in the positive direction, which is counterclockwise, and this would be our 315 degree angle. Any questions? Okay, that's good. You guys seem to be catching on really well. Alright, number 16 here. Label the 4 quadrants of the Cartesian plane at right in your notes, or below in my case. So you can hit pause if you think you know these. go ahead and give them a try on your own. We'll go through it when you come back. So welcome back. So this is quadrant 1, and then we just work counterclockwise from the positive quadrant all the way to quadrant 4. So there are your labeled quadrants. Indicate the range of angle measures for each quadrant. So in quadrant 1, the positive x-axis is 0 degrees, and the first vertical axis is 90 degrees. So quadrant 1 ranges from 0 degrees to 90 degrees, non-inclusive of either of these angles, because the angles that are on an axis are not considered to be in any quadrant. They're simply located on an axis. So then we pick up from there. Quadrant 2 goes from 90 degrees to 180 degrees, of course non-inclusive again. This is your 180 degree line right here, and you add another 90 degrees, 90 degrees, and quadrant 3 goes from 180 degrees to 270 degrees, and then quadrant 4 finishes off the rest of the way, 270 degrees to 360 degrees. So increments of 90 degrees for each quadrant. Indicate which quadrant each angle terminates in number 15 above. So for that we have to go back a couple pages. So here, this was A, obviously 56 degrees, as we still have it indicated here, is found in quadrant 1. So the angle should be labeled like this. 56 degrees. This arrow is not necessary. The arrowhead, just a little curve there, is good enough. So that's quadrant 1. And now this one, 120 degrees. And again, we'd label our angle from here. We go counterclockwise, 120 degrees. And this, of course, terminates in quadrant 2. 210 degrees, and again we still have the angle drawn here. And since this is a positive angle, again it starts here, goes around there, 210 degrees, and it terminates down here in quadrant 3. And finally this one, 315 degrees, it terminates down in the bottom right, which we know of course is quadrant 4. Reference angles. The reference angle is the positive keyword here, acute keyword here. So the positive acute angle formed between the terminal arm and the x-axis. Now, in this case, for a reference angle, it doesn't have to be the positive x-axis. It can be any x-axis. So we're going to go back and determine the reference angle for each of the angles that we just looked at. So let's start with angle A here, and the shortest angle, the smallest angle to get from this angle to the x-axis, anywhere on the x-axis, is the actual angle itself in this case, which is 56 degrees. So the reference angle here is in fact just the same as the regular angle we were given. 120 degrees. Now, we want to find out the reference angle, so the smallest acute angle. Now 120 isn't acute, it's obtuse. So we want to make an acute angle that gets us to the x-axis somehow. And of course that would be, the quickest way to do that would be right here. And since this is 120 degrees and this whole straight line is 180 degrees, this is obviously the leftover. So our reference angle in this case is 60 degrees because that's the smallest angle that will get us back to the x-axis. So for this one, kind of a similar situation here. 210 is obviously an obtuse angle, or a reflex angle, I guess. And the quickest way, or the smallest angle, has to be acute, and it has to get us back to any part of the x-axis. So this shortest way to do that would be right here, and the difference between 210 degrees and 180 degrees is the 30-degree angle in here. So your reference angle in this case is 30 degrees. And then, oh yeah, I made a bunch of unnecessary blank pages. And then for this one, the shortest way to get back to the x-axis would not be this way. It would be this little gap right here. And we know to get from 315 to 360, this is a 45-degree difference. So this would be your reference angle right there. Okay. So here's your turn for you to go ahead and try. Sketch each angle in standard position. State the quadrant in which the terminal arm lies. I'm going to make very rough sketches, but when you make your sketches, please use a protractor. Do them well, and when you come back, you can check out your answers to see how you did. Okay, so go ahead and hit pause now. So here are your answers. 150 degrees terminates in quadrant 2, 60 degrees terminates in quadrant 1, and 240 degrees between 180 and 270 terminates in quadrant 3. So there you go. So here's another one for you to go ahead and give a try. Determining the reference angle. So again, be careful when it says reference angle, because this will be the smallest angle, and it's always acute. Okay, so always less than 90 degrees for each of these two angles. Sketch both of the angles in standard position. Okay, so go ahead and hit pause now. Okay, so welcome back. So let's double check our answers here. Now, angle theta, give to you in the red marker. So this is your original angle. Now the reference angle for 75 degrees, of course, this is already an acute angle. The quickest way to get back to the x-axis is with that 75 degrees. Therefore, the blue, the reference angle, theta r, would be located in the exact same spot. And for this one, we have our red angle, which is 240 degrees. So that takes us all the way down to here, which is 30 degrees away from this vertical axis, which leaves us 60 to get back to the x-axis, and therefore our reference angle, which I've drawn here in blue, is 60 degrees. Okay, one final your turn. Let's go ahead and give it a try. Hit pause, and the answers will be ready for you when you get back. So hit pause now. Alright, so here we have an angle of 60 degrees drawn, and we want to reflect it first in the y-axis, which is your vertical axis. So if we take this angle and we reflect it in the y, it will look like this. So it's like we set up a mirror right here, and we look at this angle in a mirror, and this is what it would appear like in the other side. Now, since our reference angle is 60 degrees, that means this is 60 degrees, which means then our angle in standard position that goes all the way from the positive x-axis to here would now be 180 minus 60 degrees. So this would be an angle of 120 degrees. Okay, so let's go ahead and do the second reflection. So we're going to reflect the same angle, but now in the x-axis, so the second one here. So we start at our origin, of course, and now we're putting a mirror on this axis, so it will be reflected down here. And this is where our reference angles become important. Of course, this was 60 degrees again, which means this reference angle is also 60 degrees, meaning our angle in standard position that wraps all the way around from here to here is a full circle 360 minus the reference angle 60, so this would be an angle of 300 degrees. So let's finally take a look at our last one. Now this is two reflections. So first in the y-axis, so we reflect it over here. Sorry, that was very poor. So we reflect it over here, and then we reflect it in the x-axis. So we're going to reflect it down like this. And again, our reference angle is what will give us all the information that we need regarding the location of this angle. So this reference angle is 60 degrees, or that angle is 60 degrees, so the reference angle is 60 degrees, meaning the reference angle will always be 60 degrees no matter how we reflect this. So to get it back to the x-axis, it's just using our reference angle, which is 60 degrees. So now we know that we're 180 degrees plus the reference angle of 60 degrees, which puts the total overall angle at 240 degrees. That's it for this lesson. I'll see you in class tomorrow.